Hi folks, Mr. Ackerman here. Thanks for watching. The topic of this video is acceleration due to gravity and terminal speed. And you may recognize the term acceleration due to gravity. It's something that you learned in grade 11. If you remember our good friend 9.8, as in 9.8 meters per second squared, those are the kind of questions that we're talking about. But there is a new topic called terminal speed. Drag forces, air resistance, these are all related terms, and this is the actual grade 12 topic that's brand new for this year. So just to rehash here, here's what we're going to do in the video. We're going to review how to solve problems involving acceleration due to gravity, and that would be kind of like you had in grade 11. And we're also going to talk, sorry about this, we're also going to talk about the new idea, the drag forces, air resistance, and how that relates to terminal speed. And finally, I'm going to show you a couple of cool applications that I think you'll enjoy investigating. One new thing I'm doing in this video, and the videos from now on, is I'm going to cut and paste the lesson from your homework schedule so you can see exactly where we're at in the course. So we're in section 1.3, as you can see. Hopefully before you get to class you're going to watch this video. You're already doing that. You're going to take some notes perhaps, especially in the course pack on page 2. Take a look at the sample problems in the textbook, and if you get a chance to try a few questions in advance, that would be great. In class, we will work on those grade 11 type problems, acceleration due to gravity. Then I'm going to do a demonstration where we're going to start getting into the idea of terminal speed and air resistance and drag forces. We'll take a look at how to solve some of those problems. And don't forget, there's always a bunch of YouTube videos. One of them we're going to look at in today's video. The others are something for you to look at on your own. All right, so without further ado, here we go. In grade 11, you saw these kinds of problems. This is sample problem 1 out of your textbook, Physics 12 by Nelson. It says a ball is thrown with an initial velocity of 8.3 meters per second up. Air resistance is negligible. Now I've gone ahead and drawn the picture here of someone throwing a ball up. You see the initial velocity vector, and I'm designating the up direction as positive. That's important. Since this is a one-dimensional question where things either go up or they go down, I can just designate one direction as positive, and then any vector that points the other way will be negative. So, for example, v1 is a positive number. However, as you know, when you're dealing with acceleration due to gravity, you can write this. 9.8 meters per second squared is what you learned in grade 11, but this will be negative. I don't have to write the word down because by saying up is positive, therefore negative is down. The first question asks, what is the maximum height above the starting position that the ball will reach? So in interpreting these questions, it's a good idea on your diagram to write in the things that are important. For example, here it says above the starting position. Well, they mentioned that, so it's important. With the diagram, I can see what's going on. There's the starting position. So they're basically saying, how far is it from here up to here? This is where the maximum height will be, as you can see on the diagram. And I guess the question for you guys is going to be, how do you incorporate that into a physics equation? Because these are English words, we got to get to a physics equation. Now I'm not going to go through the whole solution, you've got that in your textbook, but I will point out some of the more important things. For example, when we're talking about maximum height, when we throw something in the air, it goes up, 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 and then it's got to turn around and come down. Well, in between rising, which I'm trying to show you with these arrows, and in between coming down, it has to stop. So the idea of a stop should be part of your thinking. And of course, the word stop, which is English, translates into physics by saying velocity is 0. This is our initial velocity down here. So for part A of the problem, this is like a final velocity or a v2. So what should you do in order to solve part A? Simple. You should take all the given information that you have. If I make a little chart here, by the way, sorry about the time lag with the drawing and how it's coming out on the screen there. Given and required information. What's given to us? Well, we know v1. We know the acceleration because we're dealing with gravity, and we know v2. It's not actually given directly, it's what we call implied information. You have to use your thinking skills in order to spot the implied information. They're asking for the maximum height here, and oops, sorry about that line, that was not too straight. They're asking for the maximum height. What is maximum height? Well, that's a distance idea. I'll use a different color here to show that. We're starting here, we're going up, up, up. So there is what I'm going to call delta D, a displacement, which is showing the maximum height. So they're asking for delta D here. And now your job is to find some equation that relates all three of these. I think most of you will recognize that the formula v2 squared equals v1 squared plus 2 times the acceleration times the displacement has everything that you need. So try using this one to solve part A. As for part B, after what time interval will the ball return to its initial position? Back to thinking about implied information. When they say return to initial position, well, on your diagram, that's right here. We're talking about the ball coming back to here. That's an English idea. How do you convert that into a physics statement? Well, the idea here is that if you go back to where you started, your displacement is 0. So this time, your given and required information might look something as follows. You know v1, you know acceleration, you do not know the second velocity, the final velocity here, because this is different than the previous question where we knew that v2 was 0. So you know v1, which is 8.3 up. You know a, which is 9.8 down. You're required to find, you know delta D, equals 0. That's the implied information. And what do they require you to find? They want you to find the time. So we're going to put in, on this side, delta T. And now we're going to look for an equation that contains all of this information. And at this point, I'm going to leave it to you to go look up your list of kinematic equations, find an equation that contains these and only these, and solve for it. Interestingly, I will point out, when you solve this, you are going to end up with a quadratic. And that's important because a quadratic usually has two solutions. How is it possible that the answer to a question has two answers? Well, think for a moment about what these solutions are going to mean. Were there two times when the ball was at this position? Yes, on the way up and on the way down. So actually the mathematics is pretty smart. It tells you, hey, pay attention, there are two times when the ball is at the starting position. It's your job to look at the two values for time and decide which one corresponds to on the way up at launch and which one corresponds to on the way down as it's falling. All right? So if you can't do this on your own and you're stuck, just go look at the sample problem solution in the book, and that should get you through that. All right, let's move on to one more, still along the lines of grade 11 style questions. They say an arrow is shot vertically upward beside a building 56 meters high. So here's the diagram and my pretty terrible attempt at drawing some guy who's firing an arrow. This is why I'm not an art teacher, this is why I'm a physics teacher. But anyway, the initial velocity of the arrow is 37 meters per second up. Air resistance, again, is negligible. At what times, there's that, interesting, plural, times, does the arrow pass the top of the building on its way up and its way down? So let's look at what we are given here and what we are required to find. We are given v1. If we want to make our lives easier, we can say positive is the upward direction, and then of course acceleration we know is 9.8 down. That'll be negative. They tell you that the building is 56 meters tall, and at this point I'd like to show you, obviously this diagram is not to scale. Someone who's shooting an arrow is not going to be like half the height of a building, and in fact there's something you have to assume here, which they don't exactly tell you in the textbook. We have to assume that the arrow begins at ground level. And the reason for that is, if you think about the question, how long would it take the arrow to get up to the top of the building right over here? Well, that would be impossible to tell if we didn't specify where the arrow began. So even though someone in real life would be standing tall, maybe 2 or 3 meters tall, when the arrow was shot, might be released from that height, even though that's the case, we're going to assume the ground because they don't tell us anything about where how tall this archer is. So looking at the question again, we're given v1 and we are given acceleration, and now they're saying what time, okay, so that's the required information, does the arrow pass the top of the building on its way up and down? Well, that would be here on the way up, and it would be here on the way down. What is special about this position? Well, it's the fact that it's 56 meters above where we started. So the implied information here is that delta D is plus 56 meters. Now, once again, the equation that you're going to use here is a quadratic. If you look up all of your formulas, you'll see that this one has everything you're given and that you need. Okay? Delta D is implied, v1 is given, acceleration is implied by gravity. And look what that gives you, a delta t and a delta t squared. This once again is quadratic, and sure enough, arrow going up, arrow going down, 2 times where we are going to be at the top of the at the top of the building, and that's the math once again looking out for you, helping you to solve the question correctly. All right. Now the next topics, if we just look back at where we started off here, review solving problems involving acceleration due to gravity. That part is now done. There's a new idea called drag forces and air resistance and terminal speed, as well as applications. Now, I'm going to include that in a second video, so there's going to be a part 2 to this, and I don't always do this, but the reason I'm doing it, I'm going to let you guys know, is that I'm actually recording this during school time on my prep period, and the bell is about to ring and I got to run a class. So today I'm going to break this up into 2 parts. Maybe one day I'll redo it, and it'll be in 1 part. But right now what you can do is try this, solving the grade 11 style problems. There goes the bell that I promised you. And the questions you'd be doing for in class, they would be these. And if you are done those and want more practice, you can do these. All right, stay tuned for part 2 coming right up. Thanks, folks.